So, gosh, what would it look like to have cosine theta just in the xy plane? If we were trying to graph r equals 5 cosine theta. Well, so when theta is 0, cosine is 1. And so when theta is 0, r is going to be equal to 5. So we'll have a point right there. And then I know that when cosine is equal to pi over 2, it goes to 0. So as I rotate theta up from the x-axis to pi over 2, I should get to 0 somehow. Maybe something like this. Ooh. And then when cosine is pi, cosine is -1. So they continue to rotate theta around to pi. They should go back, because the -1 plus the theta pointing in the pi direction, pointing in the negative x direction, means ultimately we're going to end up in the positive x direction. And then again, we're going to remain negative until we get, I don't know, I think that's it. Let me check my work. I'm pretty sure it's just going to be like a circle over here in the positive half plane. Yeah, okay. Yeah, and so without really knowing this, I just said, what does my cosine function do as theta moves? I think of theta as being like the arm of like a little clock, but it starts in the positive x direction, and then as theta increases from 0 to pi half, it goes in that. And so the direction of my vector is pointing that way, and it's going from positive 1 to 0. And if I multiply by 5, then it goes from positive 5 to 0. And then now it's negative, and it's going from 0 to positive 5, so it's pointing away, and then it's going to actually trace out the same shape as you go like that. So anyways, you might not know that this was a circle, but you know that it's some kind of shape that just lives in the positive half plane because of the way that cosine works. Okay, so we've got some shape over here, and this cylinder does not tell me what my z coordinate is, so it's going to be the same shape for every z coordinate as it goes up. And I also have to be, bounded on top by this sphere. And if we remember that r squared is x squared plus y squared, then that's x squared plus y squared plus z squared. So this sphere is centered at the origin. I know this is a sphere centered at the origin with radius 5. Or I could say rho equals 5 to pretend I'm using spherical coordinates. But anyways, to find this volume, what I would do is maybe set up a triple integral. And since I'm using cylindrical coordinates, I have to pick up an extra little r there. And I've got dz, dr, and d theta to deal with. D theta usually goes last. And then we'll try dr, dz, and if it doesn't work out, then we can swap it and we can do dz, dr and see if that works too. So theta is allowed to be anywhere between 0 and pi. And normally I would say 0 and 2 pi, but I already know that I can trace out that entire shape in the half plane just by letting theta go from 0 to pi. I don't even have to let it go from 0 to 2 pi. Z can only have lower bound in terms of theta. I don't like that. I wish that I could make my lower bound of z in terms of r, and so maybe I will change my order of integration. That way I can make my lower bound of z as a function of r. And I could only do that if I have dz, dr, right? And so now I've done theta, let me do r. So my lower bound on r can be a function of theta, and I think that my lower bound of R should be 0. I don't like that though, because then R goes negative. You know, if theta is anywhere from pi halves to pi, then R is negative. And so maybe let me change my bounds on theta, and let me see if you guys can follow why I would do this. But what if I allow theta to be anywhere from negative pi half up to positive pi half? Because if theta is negative pi half, then of course R would be 0, but then as I increase theta, I can use a positive value of R instead of a negative value of R. And so I can keep R positive if I change to using these bounds on theta. Ooh, okay, I like that. So now let me, trial and error has learnt me that I should use that. And then R can be just a nice 5 cosine, 0. That's my lower bound on R. And then the upper bound can be 5 cosine theta. Okay, and then for z is allowed to be a function of R and theta, but I can actually really easily describe my upper bound on z using this. My upper bound could be square root of 25 minus R squared. So let me do that for the upper bound on what my z value can be. And then for my lower bound, I could say that's negative square root of 25 minus R squared. R dz dr d theta. Okay, so now we just got to evaluate this thing. And we're out of time. That's the hard part anyways, like setting up the integral. Let me try to show you really quick why I chose those bounds on theta, and I hope this makes sense. So right now, can you see in Desmos how this is saying theta is allowed to go from 0 to pi? And I said this before, but if I let theta go from 0 to 2 pi, I get the same circle. And so if I go 0 to pi or 0 to 2 pi, it's the same thing, but I don't want to use 0 to 2 pi because then I would accidentally count everything twice. And if I count everything twice, it's going to give me a double volume. So I just want 0 to pi. But then, like we pointed out, if we take cosine of any value between pi half and pi, then the R value goes negative. But I really wanted to use 0 as a lower bound on R just to make my integral nice. And so I said, what if I let my lower bound on theta be negative pi over 2, and my upper bound on theta be, if it were 0, it would just go from here to here. But then if I let my upper bound be pi over 2, then it will make the same full shape. But this time, instead of starting over here and tracing like this time it starts at negative pi over 2 and it traces it counterclockwise like that. And the benefit is that the R values are always positive because the cosine values are positive between negative pi over 2 and pi over 2. So that's why I did it. That's why I swapped these bounds, and that's why I was allowed to make my lower value of R 0, and the upper value of R is just a function of theta, and that's why I chose this order of integration. And you could, if you wanted to, you could just make the lower bound of z 0 and then multiply the whole thing by 2, and that would give you the same volume, because you would be taking just the volume of the half sphere, but then you would be multiplying by 2, and so by symmetry you should get the volume of the top and bottom.